So yeah, this is Fun with Frida. We're going to look at using Frida to instrument Windows applications. So I'm James. I'm a security consultant at MDSec. If, like me, you know people by their Twitter handles, I am this guy on the Twitters. So this talk it's mostly looking at tooling. So I'm going to give you a brief intro to Frida. Sort of, for those of you that don't know it, sort of run you through what we can do with it in the Windows world rather than the mobile world. We'll take a look at some of the existing tooling that's out there, sort of go through some of the issues with that tooling and sort of things it stops us from being able to do. I've got some new tooling for you, so I've got a couple of tools to release towards the end of the talk. And then we'll have a look at a way of sort of using some of this stuff without any like extra tooling at all, if you have like C2 channels going and stuff like that. And there's some videos and stuff in there as well. So what is Frida? Why do we care about it? So Frida is a dynamic instrumentation toolkit. So this lets us inject into processes and then start hooking API calls, function calls, stuff like that. So the cool thing is we don't need the source code for the application to do that. We don't need to like decompile stuff, recompile it with extra DLLs or any of that stuff in there. It just sort of does it for us. So if we have a Fit client that's like a complete black box, we can still get stuff in there and start sort of interacting with it using Frida. It is cross-platform, so Windows, macOS, Linux, iOS, Android, QNX, whatever that is. I have no idea what that is. And it has bindings for other languages as well, so like Python, .NET, C bindings, and a bunch of other stuff. It uses JavaScript, so Frida itself is a native DLL. Some of the tooling is like platform specific, but the way it works, it uses the V8 engine from Google to sort of do JavaScript stuff. So it loads that into memory, and then your instrumentation is built in JavaScript, and it sort of stuffs it into the app for you. And the cool thing is it's free and open source, right? So we can modify this, we can use it for whatever we want with no license fees, which is awesome. So if you've heard of Frida before, like if any of you have, like wave your hands, I guess, you've probably heard of it for mobile testing, right? Has anyone used it for anything other than mobile testing? Please don't say Windows testing, because, okay, cool. So I was really worried that the whole room was going to go, oh, I use this for Fit client testing all the time, and then you'd all be bored for the next 40 minutes. But yeah, so there are loads of tutorials for Frida for like mobile testing, right? And it's normally stuff like cert pinning bypasses or jailbreak detection bypasses, root detection bypasses. Like you can find loads of walkthroughs on using Frida with mobile and absolutely nothing for Fit clients. Like very, very limited uptake for Fit client testing. If you're not sure if you've used it and you've used the objection framework by SensePost, you've used it because it's part of that framework. But yeah, we're not going to look at mobile testing for this talk. So I said a couple of slides ago, it allows us to do API hooking. It's kind of important that we know what that is and why that's useful to us. So API hooking lets us view and modify data passed into and out of functions. So if you have a block of code, you have like your arguments defined and then some curly braces and then a return statement. We can look at everything going into that as arguments, and we can look at everything coming out of it. We can't change what happens in the middle. So if you have a block of code that looks for root detection on Android or something like that, you can't change what that code does, but you can change what goes into it and what comes out of it, which essentially means you can change the function, right? You can like switch the true to a false on a jailbreak check or something like that, which is how most of those things work, just modifying return values. But if we can control what goes into a function and what comes out of the function, we don't really have to care about what happens in the function because, well, we can modify everything it's doing anyway. And if you hook enough of these functions, you can completely change the program flow, depending on what you're trying to achieve. So for something that means we don't have to do any reverse engineering, any sort of recompilation of apps, like we can do some really powerful stuff with this just by API hooking. But there is, as I sort of hinted at, limited uptake for Windows testing, and I don't know why. So I'm hoping this talk will sort of give you the inclination to go and start using this. Case in point, if you look at this GitHub repo down, over there, this has a load of samples for like different platforms for snippets for Frida. Expand the Windows one and you get a lolcat, right? I don't know why. Personally, I think there's sort of far more potential uses for Frida for Windows testing than there is for mobile testing. There are millions of Fit client apps, right, that we can do cool stuff with Frida. So I'm going to show you a demo. We're going to grab some passwords from KeePass. So there's a reason I've chosen KeePass for this sort of set of demos. So throughout this talk, we're going to see a few different examples of tooling that we can use with Frida. I'm going to use the same payload for each, just because it's easy, right? But what I didn't want to do with this talk is stand here and say, oh, look at all this cool stuff I can do with Frida. So I can do this with this app and this with this app. Because that's useless to you guys, right? Like, you might never see those apps again. What I want to do is sort of give you the tooling and the limited, like the amount of background I can give you in an hour slot to go and build your own stuff. So if you find like fit clients on any of your tests, you can do like cool stuff with Frida. And also, as I found out last year, like vendors tend to get a bit tetchy when you point out flaws in their product on stage at a security conference, and it gets like a bit nasty and a bit weird. KeePass is open source, so they're not likely to try and sue me, right? Always helps. And KeePass is already broken from a sort of pen testing point of view. So if you've come across KeePass on an engagement and it's running, you can inject a DLL into it and grab the master password out of memory. This was released years ago. You can also add a trigger if you're running as a user, and every time the user logs into KeePass, it will dump that like entire database of plaintext creds into a CSV file on disk for you. Or if you have admin access, you can drop a DLL into a folder and KeePass will load it and execute it and give you access to the KeePass vault. So I'm not giving you anything that you're going to go away and turn into malware here, right? Like, if you're going to build malware for KeePass, please don't use this demo because there are far better ways of doing it. So I'm on the video. I'm going to pause it as we go through and sort of just talk about what's going on. So first of all, you don't need special permissions to use Frida. You need the permission set relevant to inject into the process you're targeting. So if you're targeting LSASS, yes, you need system. If you're targeting something like KeePass, you just need to be a standard level user. So yeah, there's no magic here. I'm just a non-privileged user on this box. We're injecting into a process, so obviously the process needs to be running. I could spawn it in my script, but really there's very little point to that for a demo. And then I'm running this Python script. I will show you what this does and the payload we're using shortly. Essentially what this is doing the Frida injection into KeePass. And then the user comes along, enters their master password. Before any of you think I'm giving you creds to any of my accounts, these are fake creds that ship with KeePass, so don't try and spray my accounts with these, it's not going to work. And then you can copy stuff, and if you see, where are we, up here, we've like stolen the password associated with this, just by sort of being on the same box as KeePass. The little green bar in the bottom is, so KeePass has a security feature where after 12 seconds it clears the clipboard. We can detect passwords being grabbed. We can also detect the clipboard cleared event, which you can see here. And then we can copy usernames out of it as well, stuff like that. So we've not done any memory scraping here. We're not going through memory of KeePass and trying to find like creds in memory. We're just doing some hooking of function calls, and then we're able to sort of grab clear text creds out of a password manager. This will work for any other sort of app that uses like Windows Clipboard. So if you want to start building something like this yourself, KeePass is open source, so you can just go and read the source code and have a look at where it's doing this kind of stuff. So that's what I did for this demo, KeePass. You can just go and read where it's doing its clipboard interaction, and it turns out it's using the Windows Clipboard API. If it was a black box test, you could use API Monitor. So you load the app in API Monitor, and it off the screenshot, sort of over here somewhere, it has a list of filters that you can apply that sort of limit the number of API calls it returns, and you can start interacting with the app. You trigger the functionality that you want to instrument with Frida, and then you sort of go through the calls and you try and find out what API calls it's making, and you read the MSDN documents, and it gets quite complicated quite quickly, and you end up making educated guesses. And this gives you a load of output as well. So this is by far the hardest part of building instrumentation for Frida, is figuring out exactly what you want to look at. After that, it's really quite straightforward. API Monitor does support searching, so Control F, you can search for strings in like this output. For this example, that won't work because set clipboard data takes a pointer to an address in memory that contains the text you want to add to the clipboard. So by searching for like password, for example, you won't find it via API Monitor. But if you want to start building this yourself, start here and then look at some of the tools I'll show you in the next couple of slides. Once you've figured out what you want to hook, this is the JavaScript payload or snippet of it for that demo. So first of all, you get a reference to the set clipboard data API. From the MSDN docs, we know that lives in user 32. And then we pass that into this interceptor.attach, which is here. So we just pass the reference into the API call that we want to hook. And then we have this onEnter method and onLeave. So onLeave is called right before the function returns, so it lets you sort of modify the return values. onEnter is called just as you go into that function. So we want to see the data that's passed into setClipboard data, so we're doing all our work in onEnter rather than onLeave. There's nothing else down here. So the next thing we do, I said it takes a pointer to an address in memory containing the text that we want to sort of access in this case. So this is part of the Frida API read pointer, so that resolves the pointer into something that Frida can actually read. And then this is where my code gets a bit hacky. So we want to read data from memory. The way you do that in Frida is by using read byte array. We don't know how much data was written to the clipboard, so there's nothing in the setClipboard data call that says this memory location is X bytes long. That's not part of the call. So we could go and try and sort of like look at malloc calls and try and correlate it to like you call malloc here and then you immediately call setClipboard data and figure out how many bytes to read. Or you can just assume that it's always never going to be more than 32 bytes, right? And just grab 32 bytes in memory, which for proof of concept code works perfectly well. You'll see in a couple of demos later on, it does occasionally overflow and just sort of spit out garbage data. You still get the password. If you were going to use this to make some cool malware, fix that bug, because at the minute you're going to truncate passwords. And then this stuff down here, so we have a set of bytes. We call this function. All this does is turn those bytes into ASCII. I think it's just doing like a UTF-8 conversion. I'm not showing that code because it's quite straightforward. You can find it on GitHub like I did. And then the way KeePass clears its memory is this 2 dashes. So it sets 2 dashes and then nothing. That's like the way it overwrites the clipboard data. So we can detect that by looking with, so does the password start with 2 dashes? If it does, then it's just KeePass clearing the clipboard. Otherwise, it's the data we want and we just console log that. So if you want to defend your organization against this particular POC, set all your passwords with 2 dashes, because this will then never log them. Please don't do that, God. But yeah, if you wanted to sort of use this for something like practical, fix that bug as well. Just don't log it. There's no need for that to be in there. Cool. So that is a really brief intro to Frida. I could spend a day telling you about how to build stuff in Frida. There's plenty of documentation out there already that will get you started. What I want to do is sort of show you the tooling we have, some new tooling, and how you can sort of start using it yourself. So the first thing we have, if you install Frida on a new workstation, you go away and do pip install Frida, you get Frida Trace, Frida Console, and the Python hooks if you do it by pip. So Frida Trace is the starting point I'd suggest if you want to start sort of building stuff. So you've used something like API Monitor, or you've had access to the source code, or some reverse engineering if you have that skill set. I don't, but some of you will. You figure out what API call you want to start monitoring. You do all this from command line, so you just literally pass it in as arguments. So you pass in the user32 DLL, you pass in the process name, you pass in the name of the API call you want to hook, and then Frida Trace will manage all the injection into the process for you, and it just sits and starts listening for these calls. So the top call is me copying data. The bottom call is KeePass clearing the clipboard 12 seconds later. And it also will build you some basic JavaScript scaffold in the __ handlers directory. So you can then go and start interacting with that JavaScript and adding console log lines to it and doing other stuff in JavaScript. And you just rerun Frida Trace and it will then load your new tooling from those JavaScript libraries. So it gives you the basic scaffold to sort of start building more complicated instrumentation. You can add multiple API calls up here. You don't just need to do one. And you can then start sort of iteratively interacting with the process. So if you've got maybe 6 API calls, you think it could be any of those that I want to target, use Frida Trace, have a poke around in your app, trigger the functionality you're interested in looking at, and then this will spit out stuff that you can then start using in other tooling as you sort of move on developing your proof of concept. So yeah, this is a brilliant point to start, but this is all it does. You have to tell it everything via command line. It doesn't do anything else. And then if you've done mobile testing, you've probably seen Frida Console. This gives you interactive access to the process via Frida. So there's some menus in there that will do stuff. I have no idea what they do because I've never really used it for that. The way I sort of approach this is API Monitor or whatever, find out what I want to start looking at, build the tooling with something like Frida Trace or some of the tools we'll see later on. And then this I don't use as it is now. So this, you give it the process name, and you can pass it a script via the L flag. If you don't, you just get the interactive console access to it, right? If you do, it will inject and load your payload file, and then it does the same stuff that's in the JavaScript file. we're going to see this later on with some of the sort of more complicated tooling over like C2 channels, but I don't personally use this as it is. It doesn't serve any purpose over like Frida trace or like the Python hooks. So then we get Python, right? So if you install Frida with pip, you get access to this Frida namespace up here, so you just import it. This is the code that's doing the injection in the demo you just saw. So first of all, we grab the process we want to inject into by name. It does the injection, we read our payload file, and then we just load it in, and it starts doing all the stuff for us. So this is awesome, right? We get everything that Python can do, which is basically everything. And then we get access to Frida, which does like this API hooking stuff really nicely. So we can now build some really cool complex tooling. If you've got, I don't know, let's say 50 apps that you want to analyze for a type of issue, you can script that in Python using Frida and just sort of fire your payloads at them, log it off somewhere else. Like automate testing, build really cool stuff. You can, I don't know, like create some certs that you want to inject into processes and sort of see what happens when you change values. So this gives you everything that you'd possibly want, like as long as you have Frida and Python installed on the same host that your app that you're targeting is on. So there is a problem with this, and we have dependencies everywhere, right? So you need Frida, you need Python if you want to use the Python hooks. And those need to be on the host with the app that you're interacting with. So if you're like, so we're going to look at how we remove those. So the reason this came about is I ended up sort of doing a test where a client sent me a laptop with a fit client pre-configured on it. And I had local admin access to install stuff if I needed to, but for sort of proof of concept code using Frida, you would end up with a report saying like an attacker with local admin access could install Frida and Python and do some research as the user and then build this cool payload which steals some stuff, and it rapidly becomes a non-issue. Whereas if we can remove these dependencies, we can say, oh, well, they can drop this binary that they just pull in from GitHub and do some cool stuff. Like, it makes it far more impactful for the report, right? So the first thing, if you want to sort of build stuff like in that situation, Fermion by FuzzySec, this guy at the bottom here, you can pull this off GitHub. It comes as a zip file. You unzip it on your like workstation that your target process is on, and it gives you an IDE for like building tooling with Frida. So you give it process IDs and process names. There's a button over here, and then this is like the IDE window, right? So you get IntelliSense, you get key bindings. You don't need dependencies. It ships with the Frida DLL. This is, I think, like one of the JavaScript framework front-end type apps. You don't need to install anything. It just works. So this is awesome, right? Like, this is now what I'm using to sort of build my instrumentation with Frida. So you identify the APIs you want to hook. Might use Frida trace to get the scaffold JavaScript out of it, and then it's straight into here to use the IntelliSense and all that kind of stuff. And you can just iteratively develop payloads to use with Frida. But it doesn't do anything else, right? So we've lost that like sort of cool stuff with Python. We can't do that with Fermion. We don't need to install Python, but we now can't do any of the sort of automation stuff that Python supports. So it's also quite large. It's like over a 90 meg binary. So it's not like you're not going to be dropping this on like a red team engagement, for example, right? Like, you're not going to like open RDP, drop Fermion on there, start interactively building payloads. Like, that's not going to happen. And rather than console log, it also uses send. So it means the payloads you build aren't portable. So you would have to go through and like find in a place like send with console log. Like, it's not a huge issue, but it does mean you can't just, I couldn't give you a payload and say run this in this tool, because you'd have to make these changes. So this leads us on to some like the first tool I'm going to release for you. So this is using C# to wrap Frida as a DLL. I know like the normal sort of way of naming these like C# tools is like sharp something, but sharp Frida sounds terrible when you say it out loud. So Frida sharp it is. I will stick this on GitHub for you, like the repo's there. I'll give you the link at the end of the talk. So again, I will run the video. There we go. So the first thing we're going to just, I'm still just a standard user on this box. This is a new VM. It doesn't have Frida installed, which I will show you in a minute. So yeah, I'm still just a standard user. I swear I typed faster when I'm not recording it. There we go. So yeah, if this box had Frida installed, you'd now have Frida console open on the screen. So it doesn't have Frida installed on here. It might have Python, I don't know, but we're not using Python, so it doesn't really matter. And then we run the C# exe, and we get this sort of UI window. So there's a reason why we have a console window and a UI element, which I'll sort of explain at the end of the video. But we pass it the process name, we give it our payload script. Obviously, KeePass needs to be open, and then it will do the injection for us, and then we start sort of seeing console output when we hit the hook button. So it's identified the PID belonging to KeePass, it's loaded our script into it, and then user comes along, starts interacting with password manager, copying stuff, and we should see output. So it's in a different format. It's in JSON. My God, that's big on this screen. But we've still got the password coming out here. And this is the garbage data that we've read because we're reading those hard-coded 32 bytes. Yeah, it does all the same stuff, right? It's now in .NET rather than Python. I'll tell you what, I'll skip the rest of that video. So there's a reason why we have the UI element. So stand here so I can use this. This bit is a WinForms app set to output as a console app. So if you build a console app in .NET, you get the main method, and as soon as that method returns, your app exits. So what we're doing here is asynchronous, right? We're loading a process, we're waiting for a user to do something, and then we're sort of handling that sort of two-way communication between like this stuff and KeePass over here, this stuff. So we could try and do this with threading and like async waits and all this kind of stuff, or we could just use like a WinForms app which handles all this for you. You don't need to show this UI component. This is here because when I built this, I was sort of running multiple scripts and stuff like that. You can hide that. You can hide the taskbar thing over here. You can hide all that from the user, make it completely invisible, and still benefit from the sort of built-in threading that you get with a WinForms app. Just hard-code everything into the app. You can bake the script into the app as well if you want to. It's .NET. You can do whatever you want with it. But yeah, you do need that sort of automated threading support stuff that you get with building a console app. If you type to output as a console app, you get the access to console, so you can just do console log and stuff like that. So yeah, it's a C# wrapper around FreeDLL. There are no dependencies in the sense that you don't need to install anything. You still need the FreeDLL, right? That still needs to be on disk. We can't get around that. So Frida is a native DLL, which means you can't load it via reflection. So the first thing I tried with this is zip the DLL, embed it as a resource, unzip it in memory, load it reflection. Doesn't work because it's a native DLL and you can't do that. We've got sort of all the sort of customizable stuff back. So we don't have Python, but we have .NET, and you can do everything with .NET that you can do with Python. .NET is on pretty much every Windows endpoint that you will ever encounter now. It's sort of in by default, so you don't need to worry about installing anything. You can build this on the box if you want to with like MS Build, it'll still work. And we've got the size down from like 90 meg to 45 meg. So if you build this FreeDLL in release mode on 64-bit, it is about 45 meg. If you build it in debug mode on 32-bit, it's a bit higher and combinations thereof. But we're sort of half the size of Fermyon. It's better, but it's not great, right? You're still not going to drop 45 meg DLLs on like a red team engagement. Like that's probably a bad idea. So yeah, I'm already using this. I've used it with that fit client sort of assessment on a client-supplied laptop that I was talking about. Solves a bunch of problems, not all of them. We're getting better, right? You can, if you want to use this for a traditional fit client test tomorrow, you can pull this off GitHub, drop it on a customer laptop, customer workstation, build some tooling, and start using it. Like it works. It solves a lot of problems for you. So I've talked a lot about sort of managed languages like Python, C#. There are other options. I'm not going to dwell on them too much because, well, I don't understand C to any sort of depth, but you can use Frida with C. So you have Frida Gum, which uses C APIs, does not have JavaScript support, so you have to do everything via like C API calls. I don't understand C at all. If you do, and you want to go down the sort of unmanaged language route, there are options for you. FreeDGum.js has the V8 engine baked in, but it sort of inflates the size of the exit you get out of it. So this blog post down here from SensePost, they used Frida to persistently backdoor LSASS until the next reboot anyway. So this payload blob here essentially modifies the return value from LSASS to say a password is always correct for a user. And they built it with FreeDGum, and it comes out as 40 meg by the time they compiled it. Which, for me, who doesn't know C, I don't see the point in going down that sort of route of pain and misery to save 5 meg. But if you're into C, like, go for it. The options are there. So we still have to be local to the app that we're trying to assess, right? You still have to have some way of putting tooling with like an RDP session or sat physically in front of the machine on the host that the target process is running on. Like we don't have a way of running these tools over C2 channel. So we can use this for fit client tests, but there's no way we can use this for like a red team engagement or a traditional pen test where you might have compromised an endpoint and just have some access to it, but not like full RDP. So we want to change that. We want to be able to use this all over the place. There's no point you building some awesome tooling to like, I don't know, steal passwords from a VPN client or whatever, backdooring LSAS, if you have to like be at the terminal to use it. That's kind of pointless, right? So this is where we sort of introduce the next bit of tooling. So this is Frida Gadget. So Frida Gadget comes with Frida. It's a shared library that's designed to be injected into processes, and it just listens for Frida Console to talk to it. So that's what Frida Console is mainly used for, right? If you are using Frida for mobile testing, you normally sort of have a gadget running on the iOS Android app, and you talk to it via Frida Console over USB, yeah? Same concept, but now it's over TCP, not USB. And by our standards currently, it's small. It's 17 meg. That's way better than 45 meg, right? This is portable. This is something that you can potentially start dropping to disk in places and like using in sort of more traditional pen testing, red teaming type stuff. So when you inject this DLL, it starts listening on TCP. It doesn't do anything else. You're not going to get reverse shells out of it. It doesn't talk back to you. It just listens on localhost on 27042 by default. You can give it a config file, so you can change that port number. If by some weird coincidence it clashes with something that's on that workstation, you can change the port number. And it also gives you the ability to run scripts on startup. So SensePost's LSAS backdoor, you don't need to interact with that once it's running, right? It just does the thing it's meant to do, gives you sort of access via LSAS by putting in like incorrect passwords. For the demos we've seen for my stuff, you do need that access. But if you just want to backdoor LSAS, for example, you can use this config file, give it your payload.js file, drop it all on disk, inject Frida Gadget into the LSAS process, and it will just run your script for you. So you don't need to do anything else at that point. I'm not going to go into this in too much detail. Like there's actually documentation for this on Frida's GitHub page. If you've used Frida, the documentation is pretty sparse in places. This is actually well documented, so you can go and read about this if you think it would be useful to you. So this gives us the possibility to inject Frida Gadget into a process, and then it's on localhost, so we have to be able to appear on localhost, right? But we can do that via socks. So if you use Cobalt Strike and Beacon, you have socks baked in, like other C2 frameworks do this as well. So you can now run Frida on your attacker machine over a C2 channel onto an endpoint where the process you want to target is and use Frida to interact with it. So that's fairly awesome, right? So I'm going to show you something else that I'm going to give you at the end of the talk called Frida Inject. This is nothing special at all. It's literally doing DLL injection. I've sort of called it Frida Inject. It will inject any DLL you give it. It's just using Windows 32 APIs to inject DLLs. I'm going to give you the code for it on GitHub just so you can use it if you want, but build your own. It's not that complicated, really. So this demo is slightly more complicated. So over here we have a new Windows 10 VM. This is our compromised endpoint in the sort of red teaming situation. Up here we have Cobalt Strike. This machine is already beaconing back to Cobalt Strike, so we have C2 established already. This terminal down here is on our attacker machine. So the scenario here is this is in your client's environment. You've phished a user, you've got Beacon, they're using KeePass, you want to steal creds from it over C2. So again, I will pause the video in places that actually matter for this. So the first thing we're going to do is use execute assembly to launch Frida Inject in memory. So for those of you that don't know, you can launch .NET apps in memory using execute assembly in Cobalt Strike. Other C2 frameworks do this as well. So our actual .NET exe that does the DLL injection does not have to touch disk for this. The Frida DLL does. So that is this DLL here. I just renamed it Frida rather than Frida Gadget because typing is hard. So this command that I'm typing here, you give it the path to the exe you want to inject, which is on our attacker machine, the name of the process, KeePass, and then this is the path to this DLL on the compromised endpoint. So you just use the upload command to drop that to disk, right? It's on desktop because that's easy, but Windows 10 is probably fine. So yeah, Beacon will call back and say that it's done the injection for you. And then if I remember, I start doing stupid things and I recorded this demo. So what we're doing here is I'm trying to use proxy chains to make FridaPS proxy aware, but I didn't actually start the socks proxy via Beacon, so obviously it failed to connect. So then we go back into Cobalt Strike and just tell it to spin up a sock server. So what this does is it opens a port on the team server for Cobalt Strike, and then Cobalt Strike manages sort of sending socks down to Beacon on the compromised endpoint. And then once you spin that up in ProxyChain's config, I've just told it that there's a SOX4A server on port 3333 on the team server IP. That's not particularly complicated to do. So FreeDPS, this is something we've not seen yet, but this looks for Frida-enabled processes on a host that you give it, right? So if you use this in the mobile world, you give it the USB argument and it would find gadget over USB. In this instance, we're pointing it at localhost and it's found our injected gadget. If we run this over proxy chains, it would look on this workstation rather than this workstation. Because it's over proxy chains, it's now proxy aware, so it's appearing here, essentially. So we can see we've got this gadget process like there ready to be communicated with. So in the previous demos, we were interacting with KeePass, right? So what we've done here is injected gadget into KeePass, and then we're now interacting with gadget. So it's slightly different, but we're still within the KeePass space in memory. So yeah, then we do the same thing with proxy chains and Frida. So this connects Frida console to gadget on the compromised endpoint over our SOX channel via C2. And yeah, again, I derped when I recorded this video and didn't give it the process name to inject into. So it's not magic. You have to tell it what process to inject into. So you just have to tell it to inject into gadget. And we gave it the script file argument as well, right? So we're using the same payload script for this demo. And then the user on our workstation at some point comes along, interacts with KeePass, and we start like capturing credentials here. So apart from a DLL somewhere on disk on this workstation, and like C2, we don't need anything else now. Like we can start interacting with these processes over C2 and grabbing data from password managers or interacting with other apps, whatever you need to do. So yeah, I'll give you the GitHub link for this at the end of the talk. It's pretty straightforward to build your own version. You don't need to use mine, but I thought I'd give you the examples. C# app, so we can launch it in memory using execute assembly, and it just uses Windows 32 APIs to do DLL injection. It's not complicated. You could inject any DLL you want to do this. So yeah, we now have Frida via Beacon, so we can do it in memory except for the DLL. Frida Gadget DLL at the minute is AV safe. If you run the hash through VirusTotal, it's not detected by any engines. I'm sure if you all start using this to build cool malware, then it will be pretty quickly, but we can solve that problem at some point in the future, right? Like you can modify the signatures of it or whatever else you need to do. So this gives us the potential to use Frida in way more engagements now. You can build your tooling using like your exploit scripts using like tooling on a host. So in this situation, you'd install KeePass locally, you'd build this tooling, and then you'd use it on an engagement via C2. It turns out we don't actually need any tooling at all. Like we still need Frida, but Cobalt Strike has the ability to do DLL injection natively, as do like many of the C2 frameworks. So you don't need to run my like hacky stolen from GitHub C# code. You can just do it all via Cobalt Strike. So this is the same demo setup. Compromised endpoint. SOX is running over here on 3333. All I've done between like stopping the last video and recording this one is killing KeePass and me launching it just to get rid of gadget from memory. So I have to inject it again. So we'll do the same thing. Only this time we're going to use DLL load in Cobalt Strike. So DLL load will take the path to a DLL and it says must exist on target and just inject it into a process for you. And it needs the PID, not the process name. So if we want to avoid sort of running commands on the endpoint, we can use PS in Cobalt Strike, which uses like API calls to do a process listing. So our PID is down here for KeePass. So we then just call DLL load, give it the PID, give it the path on disk to the Frida Gadget DLL, and Beacon will go and inject that DLL for us into the KeePass process. And then we can do the same thing via proxy chains. We can sort of check gadget as loaded using FreeDPS. I talk quicker than I type now. That's cool. Wait for past me to catch up with current me. Then we can see we've got gadget loaded into KeePass again. And then we can do the same thing, just proxy chains, Frida console, load our payload script into it, and we've not used any code at all, rather than like the DLL that has to be on disk. So yeah, I'll let the video finish because why not? We have time. And it's going to do the same thing as it did in the last one. So the user will then come along, interact with KeePass, start grabbing data, copying the username this time, and we get the data exfiltrated down there. Cool. So we're near the end. It's almost beer time. So we'll take a quick summary, and I've got the tools to release for you. So I've shown you an example of what Frida can do, right? So what I didn't want to do is stand here and just show you like payload after payload, because it's not going to be much use to you. You're never going to see these apps again. What I want you to take away from this is like the ability to start using Frida in your own engagements. You can do really cool stuff with Frida in Fit Client world. Like if you look at FuzzySec's repo for Fermion, he's got some examples in there which are far more complicated than this. So like have a look at those. That's a really good starting point for stuff that you might want to start building on. We've got a couple more tools and techniques to use Frida in more engagements. So until like now, I think most people were sort of using this like on the same sort of endpoint as the Fit client, and then maybe sort of building a custom XE to run it on a sort of another endpoint. We don't need to do that anymore. We can do it via C2. We can do it with .NET without dependencies. So yeah, rest up to you really. There's definitely scope for further work here. So you can inject a DLL into memory completely using this sort of concept of reflective DLLs. So if you ever look at this guy's GitHub link, he explains this quite nicely. So I've tried to get this working in time for the talk and just failed for some reason. So there's a tool called SRDI, which will take a DLL, like a native DLL, convert it to a reflective DLL, and then give you the shellcode for it. And Cobalt Strike and other frameworks support shellcode injection, right? So I thought, I could just generate this DLL as shellcode, inject it into the process, it will just work, and then we don't need tooling at all. It turns out it's not as straightforward as that, so that sort of like a 17 meg blob of shellcode, like Beacon just appears to not be able to handle. It just never returns. So I built a small C# app which pulls that blob of shellcode like over the wire into memory and then injects it from C#, so we can load that app with execute assembly and do it all in memory, right? If you build a DLL that just launches calc and then run it through SRDI and inject it into KeePass, it works perfectly. You spawn calc. If you take the Frida Gadget DLL and do the same thing, it just kills the process instantly. I guess it doesn't like having 17 meg of shellcode like stuffed into it. If we can get this working, that means we don't need to touch disk at all for this. So we don't need to drop DLLs on disk anymore. We can just do it all from sort of our attacker machine over SOCKS, which is awesome because then there's nothing there for like the blue team to sort of see, like, oh, we're not dropping DLLs and stuff like that. So yeah, this is rapidly approaching the end of the talk. If you like this kind of stuff and you want to work with awesome people and me, we are hiring. So speak to me or Dom or Adam or Dee over there, and yeah, we'll have a chat about it. I will put this slide back up in a minute, take pictures. These repos are made public this morning, so you're free to go and like clone them, do whatever you want with them. If you find bugs, like feel free to fix them. If you like this sort of research and want to see more, it normally ends up on my Twitter at some point, either links to blog posts or just random stuff. That is it. If anyone has any questions, shout them out. Like, thank you for coming to see me. You have a choice in talks, and I'm chuffed that you came to see me. So yeah, take photos of the slides. Questions, shout them out. Otherwise, thank you. Awesome. So anyone got any questions, or are you all happy?
Any questions? It would be good if you had a few questions. Got a bit of time to finish off.
Sure. Shut up.
I was just going to say, if you're going to rely on the C# dependency libraries, don't go fancy the new C# 6 or something.
Oh, yeah. So, yeah, that's a good point I didn't touch on. So, newer C# has AMSI in it. 5
or below should be all right.
So, Dom will probably be able to clarify on this, but I think the standard version is 4.5 that comes on Windows now, is it? When that's going to change, we don't know, but for now...
6, I think it's 4,
yeah.
6, 2 or something.
So what people that are using this, like Ghostpack and stuff like that, they're just targeting lower framework versions at the minute, which sort of forces it down a different sort of runtime. But yeah, that's a really good point. Yeah, use older versions of C#. Like the older you go, the less likely you are to run into issues. But cool. Anyone else? Yeah.
Are you aware of any other similar tools or tooling around this kind of space?
No. So I've heard from a couple of guys on Twitter who sort of, I've done a couple of blog posts on this sort of stuff already, and somebody said they used Frida on an engagement, like on a red team gig over C2, and I got no more details on how they did it. I assume they've probably done something like this. There's not many ways you can interact with it, right? Like, go and have a look at what's actually built with Frida. There's limited sort of things you can use. I assume they were using sort of the Frida Gadget route over C2, but I've not seen anything. if anyone has seen it, yeah, it'd be awesome to sort of have a chat with those guys. But as far as I know, no. Sure.
Yeah, it's not so much a comment, more of an observation. Although thinking about it, it's a little bit less of an observation, but more of a comment. Bloody good talk.
Thank you. I appreciate it. Thank you very much. Thanks, everyone.